Problem number 4 on our exam 1 review sheet states, the CFAR company makes and sells binoculars for $45 each. Okay, when you see sells, then that should immediately start you thinking about selling price. So the selling price is $45 each. That's the figure we're going to use when we write our revenue function. One day it produced 320 pairs of binoculars at a total production cost of $11,140. So one day they made 320 pairs of binoculars and the cost was $11,140. Another day it produced 280 binoculars at a total production cost of $10,060. Part A, determine the cost volume function. Now, this time, in contrast to problem 3, this time we weren't told the unit cost and the fixed cost. So we're going to have to figure those out ourselves. We're going to have to figure out the M and the B. We're going to have to figure out the slope and the y-intercept. Remember, in a cost volume function, the M, the slope, is the unit cost of the item that we're making, and the B, the y-intercept, is the fixed costs. What are the costs that we have no matter how many of the item we make? Well, when we've solved equations or we've created equations like this in the past, we want to try to find the slope first if we can. And one way to find slope is with 2 points. And these would be our points, because this is an X value. 320 binoculars was a production cost of $11,140. 280 binoculars, that's X, was a production cost of $10,060. So these are points, and I can use those points in the line to find the slope. So I take my change of y over change of x. Well, what's the change here? 11,140 minus 10,060. That's my change of y. So that's 1,080 over a change of x, which is 40. So 1,080 divided by 40 will give me my slope, my unit cost, which in this case is 27. So that tells me each pair of binoculars costs $27. It costs $27. There were 40 more pairs of binoculars made today. And so the difference in money had to come from making those additional 40 pairs of binoculars. The difference in money spent, the difference in production cost was $1,080, and that was distributed over the 40 extra binoculars they made from one day to the other. That's $27 a piece. So now we know that our cost function looks like this. Now we just need to find B. And our approach to finding B in the past has been take this equation now and replace the cost and the x with values from one of your points. So we'll plug in 11,140 for the cost, $27 per binoculars, times 320 binoculars that were made, plus whatever the fixed costs would be. So we've got 11,140 is equal to 320 times 27. So that gives us 8640 plus B. So subtracting 8640 from both sides gives us 2,500 for B. So that tells me then that the fixed costs were $2,500. And C of x equals 27x plus 2,500 is my cost volume function for the CFAR company. Now, part B said, write the revenue function. Well, we were told in the very first line that we sell the binoculars for $45 each. So selling those binoculars at $45 a piece would generate then a revenue function, R of X equals 45X. Part C said calculate the break-even point. Break-even is where revenue equals cost. How many pairs of binoculars do we have to make and then sell so that this revenue will cover that cost? Simply set those expressions equal to each other and solve for X. So subtracting 27X from both sides, I get 18X equals 2,500. So taking 2,500 and dividing by 18, that gives me 138.8. So we would say, actually 138.9. So we'd say it takes 139 pairs of binoculars to break even. And of course, your writing on the test will be much better than mine was here. So our break-even point's 139 pairs of binoculars. Now, part D said, write the profit function. All right, so we want to write our profit function. Remember, profit function is written by taking the revenue function and subtracting the entire cost function. So we have 45X minus the entire cost function, which is 27X plus 2,500. So that's equal to subtracting those two, 45X minus 17X is 18X minus 2,500. So there's our profit function. And now we were to find in part E the profit in a day for which 250 pairs of binoculars are manufactured and sold. And so that would be found by simply taking the profit function and evaluating it for X equal to 250. So we would multiply 250 times 1,800, or times 18, subtract 2,500 from that, and that's how we get our value that the profit function would be $2,000. So we'd make a profit of $2,000 if we sold 250 pairs of binoculars that particular day. So in this problem, it took a little more work to find our cost volume function. We had to use that information about pairs of binoculars sold and the cost of pairs of binoculars made and the cost of making them. We had to use that as 2 points so that we could find our slope. Then we took that slope that we had found in one of those points to find the y-intercept, the fixed costs. And then we were off and running to finish the problem.